Now, something that's very close to my heart is how to make science fun and engaging. Now, I'm here with Cliff, who is from Einstein by Fourier education, and he's going to show us something really exciting with lemons.
So, let's say you're stuck on a desert island and you have a fan, but you don't have any batteries. Well, what are you going to do? Well, if you can get a bunch of lemons together, you can create your own battery. Wow, really cool.
That's totally what I'd be thinking of if I was stuck on a desert island.
Now, you were saying before that I'm a complete liar. Well, actually that's true, but sometimes I tell the truth. So we're going to test and see if I'm actually telling the truth this time. So we've set up here, if you look, we've set up a 2-lemon battery. We have these.
So this is a battery made from lemons.
Battery made from lemons, exactly. So we have 2 lemons connected with wires, and how are we going to test to see if I'm lying or not? Well, we have the sensor here, and the sensor, this is the judge. He or she is going to say whether or not I'm lying. So we have this set up, and we have our program here called MyLab, and it's going to measure if there's any voltage that's being produced by this lemon, or these 2 lemons together. And so I'm going to press the run button, and we see,
Looking on the screen here,
right?
No voltage at the moment.
Nope. See, there's one.
Oh,
And if I take it away, if I break the circuit, then we go down to 0.
Not attached. Then we attach the circuit down here.
And
This is the lemon not attached to the circuit. This is the lemon not part of the circuit, and then we're going to put the crocodile clip on the little piece of metal stuck into the lemon. If we keep our eye on the screen, is that right, Cliff? Is that what we need to do? So keep your eye on the screen there. There's no voltage at the moment, and we're going to put it. Is it going to be that strong? Okay, are we ready?
go ahead.
Okay, keep your eye on the screen. Keep your eye on the screen. There we have it. What's that? A kind of 1 volt. So 1 volt battery being made simply by putting, what, 2 pieces of metal into a lemon.
So wires. You have wires that are connecting the lemons, and the way that works is that lemons have juice in them. The juice has both positively and negatively charged ions. They're attracted to the metal, and they travel through the wires, and that's what electricity is.
So basically, the positive and negative ions are moving through the lemon, conducting through the wiring, but also through the lemon.
Are oppositely attracted by the different kinds of metal, and they go through the wire. And then when they go through the sensor here, it's going to tell us how much is going through. So this is a more sophisticated experiment. This is called harmonic motion, and what we're going to measure here is the weight of how gravity is. Oh, I got to start. Well, here we need a mouse here, and let me clear the screen here. Okay, so what we're measuring here is the force that is being put on these weights going up and down, and the distance, and we're going to measure it together. We'll use something called the spring constant in order to determine harmonic motion. Here we go, bouncy, bouncy, bouncy.
Oh, that's so cool. So basically the graph is showing us the distance traveled, and also... So that's so cool. The graph is showing us the distance traveled by the little thing bobbing up and down, and also the force exerted. Is that right?
Exactly.
And you can see that, I can see that they're sort of in opposition.
And
so
then the relationship between them.
so when the distance is the most, the force is the least, kind of vice versa. So it's a little inverse relationship?
Yes.
Brilliant. And so what's the sort of application of these kind of tools?
Well, this is a very sophisticated experiment, and this is a little more abstract. You learn things about force and gravity, and something called the spring constant, which is what happens. There's a constant equation with the spring, and the effect of it on force and mass.
And of course, you can see it straight away visually on the screen, so you can have a visual representation of what's actually going on in front of us. Okay, Cliff, that was really brilliant, but I have been told that I need to see the fish.
Well, when you ask that, I have to say guilty.
Come on, let's go.
So,
let's go
see the fish.
Fish.
Okay. This is Ethel and Emily here.
I'm Emily. That's very bizarre.
my intimate son. So we built a biosphere here. Now what's really cool about this biosphere, notice we have fish in here, we have plants, we have all kinds of living things. And what are we doing? Also inside, notice we have all kinds of sensors. We're measuring how dirty the water is. We'll see over the course of a week what happens to fish in a tank. We probably won't change the water, we don't really need to. The fish will not be harmed, don't worry. But what happens to the water? Well, you can guess what will happen with fish for a week. We're going to see we have Elodea in here. It's producing oxygen. What are the oxygen levels going to be like? We're measuring dissolved oxygen. We're measuring the temperature inside the biosphere and outside the biosphere. What's the effect of the greenhouse effect? Light shining in here, the light is going to warm up the biosphere. Let's see what happens if there's a difference between the inside temperature and the outside temperature. All these things are being measured, and we'll do it over the course of a week, and anyone at school can set up a biosphere and over the course of a week see what's the difference and measure all these cool things and come to all kinds of cool conclusions.
That's just amazing. So basically, all you need is a fish tank to figure out the greenhouse effect. You need a lemon for an electrical circuit and a bouncy thing for simple harmonic motion. Easy peasy, right?
It's incredible.
Thank you.
We're wonderful.
This has been really fun. Thank you very much.
Thank you very much.
That was definitely the highlight of my afternoon.